Back on the workbench for the kayak build, guys. Sorry it took me so long. We got a lot of stuff to show you in this video, and here's a little teaser. This incredible piece of history is available for purchase right now on eBay. Link is in the description. Don't forget, we're giving away a Mr. Cool air conditioner, and I'm going to come install it in your house or shop. Like Mr. Cool on Facebook and send me a message on Instagram. Let me know why you deserve the Mr. Cool unit. Okay, right now I'm just making some XT60 connectors, so I've got positive, 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 and those are all three soldered together. And then on this side right here, negative, 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 and those are all three soldered together. The solder joint is a little ugly on that one, but it doesn't matter. This is all going to get heat shrunk, and these are really, really strong, so it's a really good way to do it. Okay, so I've got four 8,000 milliamp hour batteries. I've made a whole bunch of different connectors. I've got a meter right here. The motor's sitting on the bench running. It's running full throttle right now with the 15 volts. Now, this will run 100 volts, right? So there's just a couple batteries here. There's a huge stack over there. So it will go 3 times that fast with that. And looking at the amp draw, it's only 1.4 amps. Now, of course, as you crank it up, or as you put a load on it, the amps will rise. And so I'm way lower on amps than I thought I would be. I was expecting this to be like with these batteries doing a huge draw. That's nothing for these batteries. These are 45C 8,000 milliamp hour batteries, right? And so this is 16, this is, let's see, 14 volts, or it's closer to 15, but 14 volts and 16,000 milliamp. Right, so 16 amp hours, only drawing 1.65 amps. Dude, that's fast. We're at 15.25 volts, so my cutoff will be 14, well, it'll be under 14.8. It'll be like, I don't know what one of those batteries dead is. So go big or go home, right? And this really isn't as big as I want to go. I want to go bigger than this because it's all about range for me. With the occasional boost of speed, if I want to kick it up, you know, if I want to cruise at 2 miles an hour for a couple of days, or if I want to kick this thing up and just kind of blast it out and hit that, I don't know that anything over 10 is going to be safe, but I no longer have any concern that this thing won't pull that. We are limited by hull design. You have to remember, kayak hulls are not made to plane out and get on top of water, so you will be pushing water the entire time. So there's a sweet spot in there for range and speed that'll get you there, but I think this thing will, I don't know, man. I think it's going to go. Batteries, right? There's a couple different ways to run them. You can go series and parallel, and I'm going to tell you why I chose these particular batteries. Okay, what we have here, and these are just test batteries, but I think they're going to work out just fine. Okay, ZOP power. So those of you that know about RC stuff, these are really inexpensive batteries, which is a good thing in our case because you get a ton of power at a pretty low price. I think these were like 20 bucks or something like that. Link in the description. And right here, you can see this has 2 cells, so this is a 7.4 volt, but what it has going for it is a large storage amount, okay? Now, if we were to purchase this battery pack, one this size, it would cost a ton of money, but buying them like this and then doing a little bit of wiring yourself can turn these packs into a good, respectable pack for this. So the kV on this motor is 360. So we take our 7.4 volts over here and we multiply it by 360. And that comes out to 2,562 RPMs. Now I think that that would be a fantastic RPM running down the road. I mean, that's like half throttle in a boat. So that would be pretty good, right? Your boat motors get up to 5,000 to 7,000 RPMs depending, right? Issue is, that number is not a real number because it's still based on kV and not KT. So it's not telling us what this motor is capable of running with a load of the propeller on it in the water, right? So you're going to get different RPMs based on that. In fact, that number's not even telling us how much we're losing in RPM just based on friction from our bearings. But that number gets us kind of close. So let's say it's 2,000 RPMs or maybe even 1,500 RPMs. Well, that's a great cruising speed, and that's probably good enough for a lot of people because this thing is actually pretty torquey, and I'll show you that when we fire it up. But we want a little more than that. negative lead that goes to the negative lead of one of the batteries, and a positive lead that goes to the positive lead of the other batteries, and then we have a jumper wire here that connects the negative from one to the positive of the other. So what this does is combines two batteries and completes a circuit, but it doubles the voltage. And now what do we have? What is this pack in front of us right now? Each one of these packs is now double this number right here, so each one is 16, but that number stays the same. So we have 16 amp hours, and we have 14.8 volts. The power coming out of this is sufficient to give us a little bit more RPM. So now we take the 14.8 and we multiply it times 360, and that gives us about 5,200, right? 5328 to be exact. Of course, we're going to take off, 500 or 600 RPMs, maybe even more than that. I mean, under a hard load, my guess would it'll be a lot less than that. But remember, this thing has a lot of torque. Now, 5,000 RPMs, we're getting up to some usable power there. This thing rotating at 5,000 RPMs with a good prop, we're good. We're capable. We can actually do some work. So we have our watt meter right here. We're not drawing any amps. We have 15.27 volts. Now, these packs have a nominal voltage of 7.4 each, right, or 14.8. But you can see when they're charged up, they have a little more. In fact, this one will probably almost touch 16. I've been running tests on it for several hours. It's nowhere near dying, and it's very impressive that actually works that well. So we're going to be able to check how many watts are pouring out of here and how many amps are pouring out of here. This right here is a servo controller, right? So you just crank it up and crank it down, and it controls. It's kind of like a speed controller. You don't have to have a remote. This is really good for testing, and they're like $1 a piece. So I was actually kind of planning on integrating some of these as the control device for some of the kayaks. I just simply soldered an 18650 on there, made it nice and easy. So coming out of the speed controller, we need to plug this in. All we got to do is turn this dial and the motor will turn up. We're currently pulling like in between 17 and 22 watts, right? And we're pulling anywhere between 1.4 and 1.3 amps. Now, I'm just going to use this as a brake. I'm just going to kind of grab this and hold on to this and see if I can slow it down. I cannot. It's going to burn through this and it's going to make my shaft nasty. So this thing has a ton of torque. Like, I can't stop this motor, and I'm not even slowing it down. As soon as I put a load on it, it asks for more amps. So I'll show you that right now. Okay, so your amp draw is right up here, and as you can see, running with no load on it. That means no propeller, just it's what it's taking to get the thing to spin on its own is 1.7 to 1.6 amps. 1.51, 1.3, so it kind of bounces all over the place, right? And you can see our pack voltage is not dropping like crazy because we're not using very much power at all. And then down here you can see the watts we're using as well. Okay, so I'm going to put the brake on it. Climb to 9 amps. I'm squeezing as hard as I can with my hand too, guys. And it looks like we went to around 100 watts. I gotta tell you, those numbers are crazy to me. They're absolutely crazy to me. With this 4-pack setup, and right now, let's see, this thing was running at, I can't remember what our RPM was, right at 5,000 RPMs. Very, very impressed with those numbers. I'm just super excited about that. That's going to be fantastic. So technically we're running a 4S pack, and I've got all kinds of different little pack build diagrams that I set up here, trying to figure out the most efficient way to get all the power with the batteries I have and using that one speed controller, right? The inexpensive speed controller. Because these speed controllers can get up to $400. Like some of the ones I'm looking at are very, very expensive. Now I do plan, because I want a long-term system, I'm probably going to go ahead and buy one of those. But what I'm saying is you don't have to. It's not pulling enough power. That thing's capable of 200 amps. Right now we're running at 15 volts. What I'm going to do is, instead of connecting 2 batteries together, I'm going to connect 3, right? So instead of groups of, instead of 6 groups of 2 batteries, we're going to have 4 groups of 3 batteries. So this guy right here is capable of running 7S, which is like 23 volts can run through this, or actually 27 volts, I think, somewhere in there. And that's a nominal voltage, okay? So that means just it can fluctuate plus or minus that. It can also run 200 amps plus or minus, though I would say I would derate this thing. So if we build this pack with 3 batteries, it'll be 8 amp hour with 22.1 volts. So if we take 4 of those and we combine them, and we keep the voltage the same because we have to stay under that 25 mark, right? Or else we're going to burn out the unit. We'll have 22.1 volts and 32 amp hours. Now that means if I could somehow pull 32 amps out of this setup right now, and it only went to like 9 or 10 when I was grabbing it with my hand trying to stop it, which is about what I would think we would be running at constantly because we're just pushing a kayak through the water. If we had 32 amps through there, it would run for an hour. Now that would be like, just imagine going full out for an hour on a kayak with that much torque and that much power. You're not going to do that. But if you did do it, would you do that for an hour? So looking at the 10 amp draw, I think we're going to do really, really well with the 10 amp draw. I think I can almost call that that's probably where we'll be sitting. Of course, our voltage changes, and when your voltage changes, your amperage changes too. So we'll see where we get on that. Because of the torque on this thing, once that propeller's moving, it doesn't have to move over 500 RPMs just to get the boat to move forward. So moving at that high RPM is just going to be crazy. A little tip for you guys, go to your scrap yards. If they're cool, you can find all kinds of stuff. Look at those sheets of aluminum over there, those big round ones. I'm looking for stuff for the kayak build. Look at this. Beautiful, just beautiful material. Stuff everywhere. Okay, here's what I ended up with. I got this plate here, 6160, and then a bunch of extruded aluminum, and then the piece that I thought was going to be the hardest to find. It's kind of a thick-walled piece of aluminum and super lightweight. We're only going to use about this much on one kayak, the other for the other. Unbelievable. You're going to be blown away. If I went to buy this stuff and said, hey, I need this plate that size, plate roughly this size, it would cost a ton of money. $6. Okay, so we're going to talk about this little guy right here. It's expensive, kind of expensive. I think this is a 110 millimeter prop. I might have gone bigger. I've seen the same motor operate with a smaller prop, and it really kicks butt. So this one is ducted, and the reason I went with that is it's going to help a little bit with the weeds, you know, just a touch. And we can always come back here in between this setup and actually put some more weed guards, should we choose to. So it's upgradable. All right, now we're going to break it apart, and I'm going to set this aside for a second. This is our coupler, okay? Show you how this all goes together in a second. What this does, it's got a 10 millimeter shaft over here that matches our motor, 8 millimeter shaft on this side. This came with that unit, and I ordered it specifically. So what this does is we're gonna get this as close to alignment as my skills allow. This is gonna help to couple the motor without putting any extra stress on the bearings. Now we're going to get it really, really close. We want like no run out if possible. You get this long shaft. You can imagine if you had that like floating out there, that wouldn't be that great. And if you had this propeller this close, I don't think it would be, let's see here. If you had this propeller this close, it would still work, and it does work, but it wouldn't be as efficient. So kicking it out this distance really helps to allow that water flow to get around it. Okay, and then you have one bearing on this side. And I'll make sure I set these in the right way. But anyway, one bearing that mounts up right here. And you can see this is machined to touch just the inside of the bearing. And then you have another bearing on the back of this right here. And then this is one piece with a spacer and a second piece. When you couple it all together, push the bearing out, everything feels really, really good. We got a bit of a problem. There's a huge gap in there, and this thing will just rotate. So what we need to do is we need to couple this part to the motor. There's a couple ways we can do that. We can make a big frame that goes across this thing. That will be a kind of a part of what we're going to do because we need to hold this by the motor. But what we're going to do is make a spacer, essentially a coupler plate that goes in here and holds this thing proper, because look at that. If this was off like that, we would be in a world of trouble. It would wear our bearings, it would destroy this, it would vibrate terribly in the water. I mean terribly. You can imagine something out of balance spinning at 8,000 RPMs. That would be a terrible thing. So we have to have this thing balanced properly. On this piece we have 4 coupling holes right there. And on the motor itself we have 1, 2, 3, 4, 5, 6. So I need to build a plate with the ability to bolt 6 on this side as well as 4 on this side, and we need to make sure that when we line everything up nothing interferes, like none of the bolt holes overlap, And so that's going to be fun too. So to do that, what I'm going to do is take this back plate off, and then I'm going to take this front plate off right here of the motor. Aluminum on steel is often a bit of a pain in the butt to work with. Okay, we have one set screw. Is that a push-on fit? It feels tight. Oh no, we may not be able to get that off. That's a good thing. It's probably Loctited in. There we go. Nice and tight. Okay, so here's all my measurements. That's really nice. I like it. Got everything I need. Okay, so you don't have a mill, you don't have any precision tools in your shop at all, and you want to make this part. So pretty easy. I'm going to show you how to do that. In fact, I'm going to make mine that way because I know it's going to be precise. The first thing we want to do, this thing came out of a junkyard. We've measured it. We have pretty even measurements everywhere, so we know it's the right size. Okay? What we do have, though, is we've got burrs. So I'm just going to come in here ahead of time and just take one of these precision 600 grit stones. And just lightly knock the burrs off. Okay, so we're going to run this motor underwater, and it's a brushless DC motor, and it's 3-phase. And we're not going to have any issue running this underwater because, and I'll show you, there's not a lot going on here. So this is going to be kind of fun to pull this off because it is really, really tight. We can get that guy off. Oh God, that is a proper fit. Oh, that feels really good. You know that bearing is spinning. This is a really well machined motor. And it's got really strong magnets. I'm gonna have to do this off camera. Okay, I got copper jaws on my vise, so I was able to grab this without hurting it. Okay, so let's talk about underwater. What's gonna happen? We have enough clearance here to let sand flow through this. So this right here has rare earth magnets on it, and I'm going to set it down, but I'm going to be real gentle because it's going to want to cling. Okay, I'm going to kind of like let it sit down. There we go. It wants to slam into the table. Okay, I'm sitting. I'm going to pull up as hard as I can. I cannot remove that from the table. I've got to pry it up from one side. Very strong magnets, right? That's where this thing gets all its power, that and the windings. And we're going to set it up here on the aluminum. Okay, so if anything gets trapped in here, it'll just blow through. Everything on the inside is coated. There's not really anything that can go wrong. Your bearings are a little bit of an issue, but they're sealed bearings. And you also have some aluminum bronze bushings that help to kind of locate it against the bearings right here. And those are going to be fine as well, as long as nothing gets inside here, which it's impossible for sand to get in there because the gaps are way too tight. And I'm saying, I don't think anything's getting in between that bearing, but this is open. Now what that's going to allow is water to flow through there very easily. Now we have center located. If we ever need to go back, we can just kind of wiggle this around and bam, there's center. What we're going to do now is on this really little thin line here, I'm just going to take some of this glue, drop it on a couple spots. That's good. Slide this back through. Very important you don't get any of this on your bearing surface. For those of you wondering, the super glue I'm using is Starbond, and it's really good. I like it a lot. There we go. Drop that center. Now our piece is glued to the table. It's going to be easy to get that off, though. It's not going to be very difficult. Once again, a couple ways you could go. Grab a transfer punch, come in here, slide right down the middle. Boom, 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 boom. No clamping. Okay, now we got to get it off. Take anything, put it underneath, and just pop it off real quick. Piece of cake. So without this drill guide here, we could potentially be off somewhere. Without the center punch holes, we could be off. And then our tolerances that are extremely tight would never work. Oh no, it's perfect. It's absolutely perfect. Okay, all of our holes line up. You can see the light coming through. On my phone here, I have a little diagram, and I'll put it up on screen right now. And what it tells us is that this is 46, right? So we're going to grab our calipers, turn them on, and we're going to go to millimeters. And we're going to kick it up to 46. Let's just check that measurement. It should be to center, I would assume. To me that looks a little, well, no, it's perfect. Okay, so now we can just take this guy, if and we want, and we can find that center line. We're gonna put some light under there. You can see through the holes. And yeah, she's perfect. I like it. Once again, we're gonna come set up our drill and tap guide because we want a nice straight hole. It's not as important on this one because screws aren't going through it. It's just a shaft and we're giving ourselves some play. But still, we absolutely want to have a really, really nice perpendicular 90-degree. And because it's so big, we're going to start out with drilling a pilot hole. Come in here, give it a slight deburr. Run the drill bit backwards. Helps you to center it if you run it backwards. Drop it in. I like it. Okay, I've got everything lined up here. This is not an important measurement. This is just to show me kind of where it goes. I've got my Randy Richards scribe. Go subscribe to his channel on YouTube. Check out this beauty. Oh, fresh carbide. So I'm using this end mill because it's the biggest one I have. And we got to kick up the speed a little bit for it. But I think it'll be okay. I don't know. I could be running a expensive piece of carbide. These are Niagara tool cutters, so the good thing about that is Niagara Tool has really good prices on their carbide. I'll put a link in the description, but we're gonna find out. You know, I'm new to all this. I could make some calls, but we're gonna learn. We're gonna learn from our mistakes. Let's go here. Unbelievably gorgeous. That part is so pretty. I think that was too fast because there was a lot of smoke. It seemed like there was some heat involved there. Okay, everything's to spec. We're good to set up for a test. And because I left this on, we can clamp it up in the vise and test it, which is fantastic. So, little high-speed assembly. God, it feels so good when I twist it like that. It just, I'm not feeling any resistance. Everything feels super tight. Feels really strong. And there's no weird spot that feels any different than anything else. It's kind of hard to tell with that cogging from the motor. When I say cogging, like, it takes a lot of pressure to push that motor over to the next magnetic field. Boom, you'll see it bump. Boom, boom, that's cogging. Okay. Batteries, speed control, throttle. You ready? Let's do it. Okay, so this is just a little servo controller, and I've got this little Samsung on here. And as you can see, we have 15.2324 volts, 0 watts, 0 amps, and she's ready to roll. Now, she's a little loud because she's attached to metal to the table to this, but when you take her out of the vise, she quiets down quite a bit. So every bit of motor sound you're hearing and bearing sound and this cogging, brushless motors are not quiet. So you're hearing all that. But let's dial her up. That's a lot of air coming out of there. Now I'm going to pull her out real quick and hold her with my hand and show you guys what she sounds like outside. So it's a lot quieter. This is going to be a little low on the RPM range. See, she gets louder. So it's a little low on the RPM range. We're actually going to run one more battery on each stack, and I have a ton of batteries. So yeah, we're nowhere near And we're only pushing 2.76 amps and 41 watts. Now I'm going to put a little load on it. All I'm going to do is just put some pressure on this. Nothing really happens. All right, I'm going to shut her down. The reason I'm going to shut her down is there's something about this setup that I don't like, and I'll tell you about that right now. So inside here, in these bearings, I'm worried that these bearings are going to start spinning in there because they weren't in real tight. So I'm going to get some Loctite and put it in there and attach the bearings, and we should have a good like slip fit, and I think that'll be better. I will be able to get the bearings out. I'm not concerned about that. I just I don't want those bearings rotating. Everything feels really tight. She feels solid. This part of the job is done. We do have to disassemble her. I'm going to come back in here and I'm going to clean all this up, take these edges off of here, and make this nice and round so it follows the dimensions of everything else, and then mill the top. And yeah, but other than that, guys, that's it. She works. She's fantastic. Once again, that is the 56-114, and that is 114 millimeters long and 56 millimeters wide, and the 360 kV. That kV is important. Every volt we put in, we get 360 RPMs, and we know we're at 15 volts. So 15 times 360 is what we're running RPM-wise. Now I've got a digital tachometer coming, and we're going to test that number, and then we're going to do some water tests. I'm not going to do any thrust tests or anything like that. It's got a pretty good sheet on the thrust test, and I'll put that up when we start the actual testing. But next video, you're going to see me build the attachment point for this to the kayak. Now I know a lot of you guys are saying, "Man, I just don't think I can do that. That my skill set doesn't allow that, or I don't have the money to buy all those tools." It's not a lot of tools. It's drills, maybe 30 bucks worth of tools on top of your drills, and you can get this done. But if you cannot do that, and the amount of money that you're putting into this, which is like $220 and then 200 bucks here, and then this little guy is dirt cheap actually. There is another system that I just purchased, and it'll be coming too. And so it's kind of unique. It's kind of different. It's interesting, and I'm excited about it. And then I also have some other tests I want to do. I want to see about attaching a propeller straight off of this as well. So we'll see if we can make it easier for you, because really you don't need all this. This was me. I wanted this. What you do need to be able to do is attach a plate to this, or some rings around this, around the motor. And guys, that's as simple as taking a piece of flat metal, putting it across here, putting some clamps on it with some rubber around it, and then bending that metal up to go to your boat. I mean, it's not complicated. You can do that very easily. This was my choice. I wanted to do it this way. I liked this. This is for me. But you can go to the same place, that Kinji, and you can buy any prop for this motor, any size. So you can literally take this motor, this prop right here, and put it on this motor. You just have to custom order the shaft at 10 millimeter. Very simple. I also want to machine a coupler for this guy right here. Incidentally, the new motor that's coming has a prop this big. So, but anyway, that's a huge prop. You really need like a 100 kV motor for something that big. That's just a monster. The thing is massive. I mean, shoving a couple of horsepower through that, and you're, oh my gosh, man, it's nuts. What does this convert to right now as far as how much speed we're going to get? Well, we're dealing with a boat style prop with a mean pitch on it, so we don't really know yet. It's a 3-blade prop. It's pretty neat, really nice prop, but we have to test it. We got to put it in the water, and we have to see how fast it's going to push the boat. I can tell you this, the Bixby Jet, it's got a considerably smaller prop than this. It's probably half this size. Not quite half, but it's a lot smaller than this. And this thing right now is cranking up those RPMs, and it's not even to where we're gonna feel like we're nowhere near done yet. Also, cavitation, I think it'll be less of a problem with this shroud on there. I'm not sure. We're gonna find out. Hopefully this will help us with weed intrusion and stuff like that. We got some pretty big weeds out here, and I can come back in and actually put a screen over the top of this, and that's super easy. You don't even have to make one. You just get a computer fan screen and stick it over there, and you're done. And you only need that on the back side. You really don't need it on the front unless you're backing into stuff. So I didn't show you reverse on this because this does not have reverse, but when we get the controller set up, we will actually have reverse on it. Okay, I wanted to show you the bracket after I finished it up. Boom! And then we've got the back side, and we have a taper, because if you notice, this side fits right there. And then it tapers down because the diameter motor is actually smaller. And so we have a little bit of a taper there. Yeah, it looks pretty good. I like it. So this part's going to point up, and we're going to drill and tap this, and then we'll have our motor mount come over and then capture the motor on the back. And that'll be in the next video where I build the mount, and then we'll actually be able to get it on the water and test it.